Alright, so we just finished the last example from 7.2. Otherwise, 7.2 was talking about different names for what the math ends up doing or showing. Equivalency to equivalent equations will cancel out and be 0 equals 0 or some other true statement like 4 equals 4, etc. Equivalent systems, you just multiply equations by some constant and keep it all balanced. They should have the same solution. Consistent and inconsistent. If the math, if you get a true statement with no variables, infinitely many will be your solution. There could be different types of infinitely many that we're going to see in section 7.3, but for right now that's enough. If you get actual numbers, that means there are finitely many, still consistent, but you have a certain number, a finite number of solutions. And then if you get a false statement, no more variables, then that's no solution. And then we talked about elimination, substitution, and then we were good. So let's go ahead and check our 7.1. The evens. I'm double checking that I have the correct evens. So we need 4, 6, 10. 4, 6, 10. So far so good. What else do we got?
26, 44, 30, 60.
26, 44, 60,
62.
and 62. Is that it? Perfect. And then section 7.2 will wait in grades tomorrow. Some of you guys taking tests yesterday, making them up, and some of you guys saw that we had an extra day, so you might not have totally finished it. Let's zoom in. It's really weird because, I don't know, number 6 didn't fit on this page. So all we have so far is 4. Breaking even. Cost equaling profit. That's one example of breaking even. Number 6. Now, they showed tons of work, but all they were doing was plugging in and checking, right? Some of you did mental math. A is yes, B is no, C is no, D is yes. Yes, no, no, yes. Yes, no, no, yes. True, false, false, true. Number 10. Now, once again, they're showing all, guys, you don't need to write anything out, right? Our math should speak for itself as to what we're doing. They decided to substitute, which I would probably have done as well. Could you have eliminated and subtracted and canceled out the y's? Sure. Whether you substitute or eliminate, you should have gotten finally to x cubed minus 3x is 0. If you guys got stuck there, you just forgot to factor. Set each factor equal to 0. Plus or minus root 3, you had 2 different solutions for x from that second factor. Then, once you have x values, what do you got to do? Go back in, plug them in, and there's almost always an equation just waiting to be plugged into. So you had your x's, you went back and plugged each of them in, you end up with your final solutions, which are messy, but right. Messy, but right. Alright, let's keep going. Number 26. Did anybody amazing decide to multiply the bottom equation by 100 to get rid of the yucky decimals? Oh, no. If you don't like decimals, you could have just like bump it up, bump it up, bump it up, and you would have had 4x plus 6y is 63,000. That might have been easier to do elimination, but otherwise, probably no one used elimination. You probably used substitution, which is okay. Trying to help you with the mental math would have been easier the other way, probably. It's not letting me do anything. I don't know why. Oh well. So, solve for one, plug into the other. You could solve, but most of you would have been using calculators, whereas possibly if you had just multiplied by 100 and moved your decimal, mental math might have been easier. But at the end of the day, you end up with x is equal to 4,500, y is equal to 7,500. Those correspond to your different interest rates. Did you guys have to make up the equation?
Yes.
A little bit trickier. I think you were, investing $12,000 total using 2 different accounts. So that's why there's an X and a Y, 2 different amounts adding up to 12,000. Or you could think 12,000 was split into 2 different amounts. Part of that was in a 4% account. Part of that was in a 6% account. Trying to see what's your total interest? Is that what that is? Or how much money you're making on your investment? So anybody know, just real quick, practical, real life, there's, I don't know, silly things going around. Is it Facebook or Insta or something? about college kids that are like, man, I wish that high school taught me like practical stuff, like how to do my taxes, and, like personal finance. Anyway, so coming back. They don't totally tell you to do your taxes per se, but they talk a lot about credit cards. Anyway, personal finance, super practical. Talks about credit, talks about investments, talks about like college and spending and saving. No, but their point is that high school is not at all practical. I'm like, there's some classes that are practical to everyday living. Nutrition. Anyway, how to get into college. Because you have people with like bachelor's degrees working at McDonald's. If you don't have a bachelor's degree, where are you gonna go? Anyway, real quick, why would someone invest in two different accounts? Some of you hopefully are like, why didn't they just invest all of it in 6%?
Because then it would be a big risk.
Yeah, there is something called different investments. Some of them are high risk, some of them are low risk. Usually, the higher the risk, the bigger the the bigger the profit. Eventually. But if you're trying to make an investment for right now, you might want to be in a safer investment, just so you're not losing everything, as opposed to putting everything in a higher risk. And then there are something like, is it the money market accounts, where you can only invest so much money anyway per year, I think. So maybe you couldn't put the full 12,000 in, or maybe this one, like it's stuck there for 10 years and you can't touch it. This one, well, maybe you can touch it if some emergency happens. Anyway, real life. Yeah. 44. Personal finance talks about all of that stuff. What I just said. 44. Were you guys using math or were you using your grapher?
Grapher.
Really?
To solve graph.
Okay, I would have rather done it math, but that's okay.
It's self-grapher.
If it says solve graphically, couldn't you just say, hey, use a circle centered at 0, 0 with 5 and 5 and 5 and 5? Then you could have, how do you graph this circle by hand? You move it over, it's going to be shifted 8 to the right, and then it's still, remember, x minus h, y minus k. Has a center at 8, 0. You would have had to approximate root 41, which is somewhere between root 36, 6, and root 49, 7. Maybe 6.5-ish, could have gone boom, 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 and known that you had an intersection there, intersection there. But how would you have put this in your graphing calculator? How did you put it, those of you that got it to work? Solve for y by subtracting. And then when you do a square root, why are there 4 equations? Because?
Positive and negative.
Yeah, you did graph positive and negative. Find the intersection. Remember when your graphing calculator asks you, it says first curve, second curve? You have to make sure you're choosing the right first curve, second curve for one intersection and the right first curve, second curve for the other intersection. Does that make sense? Any questions on graphing calculator stuff you guys weren't able to make work last night? All right? Okay. Just double checking. The intersections 3, 4, and 3, negative 4. Last but not least, number 60. Oh, we have 2. 62 though is just to put into your calculator and then find the intersection point. The wording might have made it seem more complicated. The 62, you just find the intersection point using your calculator, calculatrice, calculatora. But 60, I think you guys had to make these equations, right? Who was this, a car salesman? Or did they not even tell you? Just some guy getting a job? Real life. Some jobs are based on commissions. Like what? Car salesman. What else? Okay. Refrigerator salesman? Anyway.
Maybe like telecom.
I think even, doesn't Bath and Body, like things like that, doesn't that work on commission? Because then when you get to the counter, they're like, hey, who helped you today? Have you guys ever got that? So no. Poor Jane. Anyway, so sometimes they're asking you because sometimes the people get perks, or like at makeup stores or whatnot, people can get perks by being the one that encouraged you to buy a certain product. Have you guys ever walked past those makeup counters in like Macy's or something? They totally make commission. That's why they're trying to get you to like sit down and like, I don't know, try different products because hopefully you can buy it, then they get commission on it. Anyway. Oh, they're trying to sell me, Tyler?
$16,000 per week.
Or like Christmas time, the little people in the stands in the mall? Come on. You've been chased down by them, haven't you? Anyway.
You would chase me.
Well, they like to chase people. Or at least like, hey, come over. Anyway. So, What are they doing? Trying to get a commission, which is some sort of percentage of the profits. But here's the idea. Would you rather a higher commission percentage or at least some money if you sell nothing? You guys get the difference? Salary says, okay, at least you make some money. People on salary make a set amount no matter how many hours they work. Some of your parents work hourly, some of your parents work salary, some of your parents get commission, some of them don't. All good questions to ask. Long story short, this question is all about which one's a better deal, which one should you actually choose to have. It depends on how confident you are, and this problem lets you know, well, it's going to be a better deal to get the salary plus the little commission if you sell less than $16,666.67 each week. Which, if you sell a car a week, I mean, you'll make that, right? Unless you're a used car salesman, then maybe not. If you sell a new car a week, you'll be totally good. If you sell even a new car every other week, depending on where you're selling cars from, just using that as an example, you still might be all right. But if you're not selling that much, you're not making as much or maybe even anything. So anyway, just the difference between you'd have to sell more than that in order to make the higher percentage better. So you just set one, set it greater than the other, and you're just trying to figure out where's the break-even point between the two offers so you can make an informed decision. 62 is an intersection of good. All right, cool kids. With that, are there any odds where we got stuck? Okay, hopefully 7-1 was easy, except for maybe the word problem. Is that about right? Let's go and get out of that. 7-2, we'll grade tomorrow. We'll talk about tomorrow. You guys don't need this unless you want to write down the homework problems. I'll leave it up if we have time. Okay. All right. Maybe we have time. If you guys want to write down 7-3A. If you want to write down 7-3A, if you've already done 7-2. Let me give you a few moments for that. If you want to write down 7-2. Because we've only finished 7-1. We have a few extra minutes today, so let's go ahead and write that down. Yeah, see? Hey, our board is weird over there. You guys write whatever you need to down. Let me go fix our board. Because our homework numbers are weird. Is my sheet off or was the board off? What was homework 6.6? 6.5? Whatever the last one was that we did. It was 40 to 39. Oh, okay. So the computer is right, the board's not right. I wasn't sure if you meant whiteboard or smartboard.
I could do it.
You can write mine, Jesse. Are you? Yeah.
That's it.
All right, cool kids. Those of you guys that did 7-2 and fully attempted it, how much space did it take? 2 pages? Hey, look at those kids that were working on it. Go team. I did at least 3 or 4. 7-2 is pretty easy? Good. Careful, look at the backboard. What did I technically also make do tomorrow? Ooh, let's see what 7-3A is about. And why I'm thinking, look, I split 7-3 into 2 parts. Why I'm thinking you should be able to do that. Here we go. The air is on, we can wake up finally. It's a little too warm in here. Ready, set, new section, new side, and go. My question to you, which is better?
Whichever one you want.
No, one is clearly better.
Right.
Depends who you are, I suppose. you're a teacher trying to put a tricky problem on a test, then I suppose this one's better. But if you're a student, you're like, I want this to be solved as quickly as possible, hopefully you choose that one is better.
You take from the math block or three equals.
I don't know about that. It's not that very many people would be able to solve the left one, mental math, like completely mental math. So most people would want to just use matrices, but that would take longer, I think, than solving the right one mental. Right, like theoretically mental math on the right would be faster than row echelon form. Row echelon form. As you guys are writing down the system, row echelon form refers to the one that is easier to solve, that is good for back substituting. At the bottom of the page, my way of remembering row echelon form, without getting too technical and specific, even though there are some technical descriptions as to what this form is and exactly what it's supposed to have. I just like to call it the stair step. Technically, a stair step where each of the far left terms has a leading coefficient of 1. But I like to just think of it as a stair step. So which one's the stair step? Why is the one on the right so much better?
Because you can start with one and then go to the
Start with what?
next.
Where are you going to put it? Where else are you going to put it? And what are you going to use this to solve for?
X, Y.
And then once you find y, where are you going to plug that into? And then what are you going to be able to solve for?
Y. I mean X.
Incorrect.
I'm just saying letters.
The reason we love the stair step is because you already have one solved for. Go plug it in the one above, solve for the other. Go plug both of those up above and solve for the last. Now the struggle is not all problems in section 7.3 look like a stair step yet. So if they don't look like a stair step yet, we're going to be given yucky ones like this. And in order to solve them by hand, which is our objective for right now, oh, how much more we would like it if it was in the stair step pattern. So our objective is to take a yucky one like the left, to make it like the right, and then be able to quickly, simply, efficiently solve it. Now, there are just a few of you out there. I'm going to teach you a system, how to go from the left to the right. There are just a few of you out there that are like, no, I want to make my own system. I want to do it my own way. And depending on different problems, you might do it different ways. My question to you is, why should we, in this day and age, be trying to figure out systems of solving? What is something very popular today? Advancing very quickly today that needs systematic thinking.
Oh, wow. Computer science.
Why? Why does computer science need systematic thinking?
Because everything's done with computers now.
True, but why does it need systematic thinking?
Because you go from one thing to the next program.
In programming, you have to be able to go from one step to the next or take different inputs, take different situations, scenarios, problems that could be given that the user could ask for, the user would want to do, or different answers that could be given, and you need to be able to process that information, not you specifically, but your program. And you need it in an efficient manner. We won't talk about efficiency today, that's more Calc C, but we will talk about systematic thinking where it is beneficial to have a system that works every single time, then, for computer programming specifically, then to have to think of a new system every single time you see a new problem, right? Some of you are like, I just wish there was one way to solve it and I could use it every single time and it would be right. That's one of your complaints about some of the higher math. I wish there was just one way to solve it, I could use it every single time and it could be right. Guess what? In this section, I'm going to show you one way to do it that will work every single time. And it'll be right. Sound good? Okay. There is like a couple special cases where computer programming, the system will break down, which means that the programming that's been put into your calculator to help matrices solve things like that wouldn't be able to solve some of the homework problems that you're going to be given. Hence why we're not talking about matrices first. We'll talk about them later. But we're going to try to look at the thinking that's gone into the programming of how your calculator can solve some of these. And we're not getting into the calculator until chapter 8 for these types of problems. We're just kind of introducing the idea, seeing the math behind it. And just a quick heads up, I know we don't currently have AP Computer Science, but an old AP Computer Science teacher, Mr. Moffat, the computer guru of our campus who still comes back from time to time, would always come in this class in pre-calc and in calculus and say, you guys are the ones that could be doing computer programming. Why? Just to be able to make it to this class shows that you have the type of logic that is required in computer programming. Some of you have it better, some of you have that logic, like you're more logical in that sense, some of you just work really, really hard to get here. But the logic that it takes to have a problem, to find a systematic approach, and to go through the steps to solve is exactly what computer programming necessitates. Anyway, quick little plug for computer programming, computer science. It's a huge field. It's a tricky field. It's a always changing field. But if you are in this class, maybe you should try it out. And if not in high school, then in college. But there are tons of things online that you guys can start playing with programming now. Row operations. Let's see. Let's not write all this stuff. Long story short, when we go through the system, we have to keep the system's equivalent. We cannot illegally change. We have to be very, very careful that we're distributing when we start multiplying, that we are canceling correctly. A name for this process, Gaussian elimination. It's named after that mathematician. Gauss. Is it Friedrich? Gauss, I think. But it's named after Gauss. Long story short, you can interchange if you have two equations, you'd rather them be in a different order, no big dealio. You can, once again, multiply an entire equation by a non-zero constant. My warning, watch the distribution, be careful, watch the errors. And then you can use elimination. We've already basically talked about this chart. Here's what I want you to get down. For our system, it's going to be a chain game. A chain game to the stair step, a chain game to get to the row echelon form that we want to solve with. Even though you guys are writing a lot, as soon as we start doing problems, hopefully you'll start to see the system that I'm going to show you this. Once again, not to say there aren't creative approaches. And eventually the system will break down on very special types of problems. Which is why the programming in your calculator would break down on the exact same problems. Otherwise, the system will always work. You'll see the difference. Probably tomorrow you'll see the exceptions. So we're going to use the exact same example that we started class with. This one, that the left was gross, the right was nice. We're going to see, well, how can we make that jump? It's not a jump. It's actually 3 jumps if it's a 3 system. 3 equation system. It's actually 4 jumps if it's a 4 equation system. It's actually 5 jumps if it's a 5 equation.
Can you go back? I think I copied it down.
Oh, to the page before?
Yeah.
Is it just the equations?
Yeah.
You'll actually see them again in a second. Is it that side you got wrong or the other side?
That side.
Got it. There you go. Alright, the system is all about links. Chain game. It's all about links. Unless you start interchanging equations, we're going to link the first two. We're going to link the second two. And there's a third link just waiting to be formed. We're going to link the first two. We're going to link the second two. There's a third link waiting to be formed. The name of the game is in the stair step. Let me get rid of this silly menu on the left. Sorry if that's annoying you. There we go. Okay, grouping the first two. Question. When we bring it over to solve, the first link, do we need to multiply anything in order to eliminate? No. And more specifically, just so that you guys know, for the first two links, we want to eliminate the x terms. We want to eliminate the x terms specifically. We're trying to form our second stair. So actually, to be honest, we can start right away and say, yay, you're a keeper. This can be the first equation in our stair-step system that you guys will see a little bit later. He's a keeper. Why? Because he has one x in front. So he's a keeper, but we got to go find another keeper. We're going to do that by eliminating the x terms. How do we eliminate?
Elimination.
It's ready to go. Just add down, right? If it wasn't ready to go, we would have done some multiplying. The x's cancel, which is exactly what we want. 3 minus 2y is 1y plus 3z. 3z plus 0 is itself equals 5. Why am I going to say this is another keeper?
Because it has a 1.
It has a 1y. Good, and no x. He's a keeper. He's my second stair. I need to find my third keeper. That's okay. Follow the system. We've done the first two. Now we're going to link the second two. But wait a minute. Can I add down and eliminate the x's with the second two?
No.
No. Well, stink. But what can we do? Sure. Can we multiply the top one by
2.
2? Sounds good to me. Let's multiply this top one by 2. We didn't do it for the first one, but we will do it for the second one. Make sure you distribute. You got to be careful of your math. Negative 2x plus 6y equals negative 8. Are we all right? 2x minus 5y plus 5z equals 17. We set it up in order to eliminate. 6 minus 5y is y, plus 0 plus 5z is 5z, 17 minus 8 is 9. He's a keeper. No, he's not.
We already have
I already have 1y. Does that make sense? I have a 1x1, I have a 1y1, now we need a 1z1. Well, how do we? We form a third link.
the 2. But can't you use the y plus?
Time to link these two. And they're not written together, which is a little bit annoying. We could have done it if I had more room side by side, then link them together. Either way. We need our last link. Now that we have two equations with y and z, let's use those two to eliminate the y's and get the z by itself. So we have our first one, y plus 3z equals 5. I'm going to multiply the second one all by negative 1, right? Negative 1 minus 5z equals negative 9. Why did I do that?
So you can cancel y.
Yeah. Get rid of those ones. I end up with negative 2z equals negative 4. It's a keeper, not
No.
quite.
Equals 2.
Exactly. Technically divide both sides by negative 2, z equals 2. Now I have a keeper. In programming, you could always make the first two terms match in order to eliminate the first two equations. The first two terms match in order to eliminate the second two equations. You could follow the system, you could program it in order to be able to make this process work. And once you have the stair step, once you have the third variable, all you gotta do is compile them together. Sounds easy, the programming would be somewhat complicated, but the system would work. Now kiddos, we said that this system, once you got it into the stair step, was great for solving, so let's prove it and let's solve it, okay? What do we already know?
Z is equal to 2.
Got it. So let's back substitute. Y plus 3 times, plug it in, plug it in. So plug in that Z, right? So y plus 3 times 2 equals 5. Which means y equals,
-1.
exactly. Subtract 6 from both sides, y equals -1. Now we're going to go all the way back to the first equation and plug in both the y that we have and the z that we have. Doing some mental math, hopefully carefully. X plus 2 plus 6, x plus 8, subtract 8, x is equal to,
1.
don't worry, you don't have to do it mental math, I'm just doing it for sake of time. Solve for x, you get x equals 1. This is a 3-dimensional system because we have x and y and z. So we keep the x, we keep the y, we keep the z, and we say, dun, dun, dun. This is a consistent system because we have one finite solution. So what was the system? Link the first two, get rid of the x's. Link the second two, get rid of the x's. Link the results of both. Get rid of the y's. Stair step. Plug it in, plug it in. It's messy, but it's a system. What do you guys think? Can we repeat the process?
Maybe.
Maybe. What's wrong? Oh, it worked out? Okay. We'll do that one later. There's no problem. There he is. He got in the wrong page. Sorry, I don't know why he's hiding over there. There's 32. So let's do another example. What do you guys want? Do you want a minute or two to try starting the system? Okay. Let me give you a couple minutes. We have them. I'm just going to help out a little bit. Link the first two, take them off to the side. Get rid of the x terms. Link the second two, take them off to the side. Get rid of the x terms. Link the results. Get rid of the y terms. Back substitute in your stair step. As you guys start, let me take roll real fast. Are people dropping like flies with this cold thing? Well, technically that's right, just not quite the right context. We do want her to rest peacefully. She has to get better before that field trip. Is that next week?
I don't know, sure.
I think so.
Some AP Chem, AP Bio.
Just go ahead and do that research question.
Oh, wait, I think 24.
Yeah. My turn, can I start? And there are different ways of going about it, so some of your in-between steps might look a little bit off, but we should arrive at the same answer as long as we follow the same system. Your mental math skills are being put to the test. Multiplying, distributing, combining. So we gotta get our second stair step that only has y's, right? Now technically I haven't kept any of them yet. Because all of them have like numbers in front, and I'm like, maybe I'll make the leading coefficients of 1 later. That's my idea anyway. You guys need to see my separations.
To get the y, can you divide by 5 and get what's that equal?
Anybody else get z equals 0? That's a keeper.
That's easy.
What are my other keepers gonna be?
Y plus b.
X plus
Or actually
3y plus 4z.
I'm gonna use that one for my keeper, and I'm gonna use this one for my keeper. We want to get leading coefficients of 1 if possible.
Oh yeah. Oh yeah.
To technically get row echelon, I'm gonna divide everything, but you could, if you were afraid of fractions, you could leave it alone and you would still be able to solve. That was my first one, everything divided by 2 to get a leading coefficient of 1. My second one, everything divided by 5 to get a leading coefficient of 1. And my third one will z equals 0. Ha-ha! So then we can go ahead and say, hey, we got one. I got you a z. We can plug in. Y plus 0 equals 2/5. Oh, sweet. So what does y equal? Then I can plug in x plus 1/2 of 2/5 plus 3/2 times 0 equals 1/2. That's just 0. X plus 1/5 equals 1/2. The 2's reduced. Maybe some common denominators like x plus 2/10 equals 5/10. Subtract 2/10, x equals 3/10. Nice.
You don't
I
care.
have a question.
Now give me 1 second, I'm just writing it.
Yeah.
Whew. Who got there before me? At least at the
They're
same
at
time
the
as
same
me.
time.
Nice, nice, nice.
Yeah,
Question, Jane, what's up? Sorry, say it one more time. I took my 3 keepers, you see them, my yellow stars, and what I did was technically in a stair step for row echelon form, you're not supposed to have a leading coefficient of anything other than 1. So what I did is I multiplied this whole guy by 1/2 in order to get a leading coefficient of 1. So multiplied by a half. This guy, I need another leading coefficient of 1, technically to be in the right form. So I multiplied everybody by 1/5 to get 1. And then for the z equals 0, he was fine because he already had a 1. You technically can leave it, and then you will be able to solve. Just if we were following the system, we would get leading coefficients of 1, which is why when you do this program in your calculator, you get a 1, 1, 1 along that main diagonal. Yeah, Caleb.
I did the second one, I divided by 2 from the second one, and I got the same answer.
Oh, no, that's totally fine because you're keeping the system equivalent in the sense of you are getting an equation with a leading coefficient of 1. So it might be that like you're in between, like it looked differently than mine, but it still came out with the same answer. That's perfect.
Okay.
That's perfect. The same thing might have happened if you had made the second equation times -1 way back here in this first initial step. You could have multiplied the second equation by -1. These numbers might have been different, but they would have come together to be the exact same thing. So as we've seen today, as long as you keep the systems equivalent, it doesn't really matter as long as you're still following the system. Doesn't really matter the order of events that you go in. Or there might be a certain results. 7-3A, protect.
Yeah.
You're gonna miss the first base 7-4. Thanks, Maddie, for letting me know. System made sense?